Welcome to Data Skeptic. Data Skeptic brings you discussions about how data is changing our world. Our interviews are conversations with thought leaders in topics like data science, machine learning, and artificial intelligence.
Our topic for today, Linda, is the theory of formal languages. So, how do you talk all proper and stuff like that, right?
Who, me?
Yeah.
No.
You studied abroad in England. You must know a few sirs and madams and stuff.
No.
No. Did you find that people spoke considerably differently while you were there?
There's a few words, but we all understood each other. We're very similar culturally.
So if I were to claim that languages are very mathematical, how do you regard that statement?
I wouldn't regard it either way. I would then ask, what does that mean?
Well, that's a very good question, yeah. We can describe languages in terms of their mathematical constructs and what types of machines it would be required to be able to recognize statements in those languages.
What kind of machines?
Yeah.
Why do you care about that?
Because then you can get a machine to do the thing you want to do or to understand the language or who knows what.
You need to identify the types of machines?
Yeah, essentially. Maybe it will help to go into an example. Do you know much about how sheep communicate with one another?
Well, as a child, we're taught bah.
Yeah, that's right. That's the sheep language. Bah, 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 right?
Yeah, I don't know. But that being said, they seem very social and also visual, and communal.
Yeah, as listeners to the show will know, they do experience pain, and facial recognition algorithms are able to detect that.
Oh, yes, I remember sheep.
But that aside, how might we formalize statements that are in the sheep language and those that are not? For example, our bird, what are some of the things our bird says?
She speaks English.
Yeah.
Yeah, she says, hi, I love you.
Mm-hmm.
You're a good girl.
Yep.
Lindy. Yoshi. She
Go on.
says her name. Go on.
Yeah.
Yeah.
Now, would you ever expect to hear a sheep saying anything that Yoshi says?
No, sheep aren't mentally set up to speak English.
Yeah, it seems to be true. So how might we describe their language? If we wanted to hear a recording of an utterance and decide if that was a sheep language utterance or an English language utterance, you'd be able to do that pretty quickly, I imagine, right?
Oh, yes.
Now, what if instead it was recognize statements that are in Russian or statements that are in Swahili? Do you think you could listen to recordings and discriminate between which of those two languages you're hearing?
Yeah, probably.
You think so?
I feel like
What do you know about Swahili?
they would sound very different.
Well, I mean, both would sound quite different to your own ears, I would think, right?
Well, I think we could recognize Russian, and then Swahili, we'd probably just be like, okay, we don't know what that is. So that's probably Swahili.
Maybe. But certainly, like, between Mandarin and Cantonese, I would imagine you couldn't tell the difference.
I don't know. I have never listened to them.
So interesting that there are these languages that are obviously very different. I mean, maybe they have some common roots and things like that, but we don't say that they're dialects. We don't say that they're just like regional versions. These are entirely separate languages. And as independent as that may be, your brain, which can't recognize those languages directly, I mean, you can tell the difference between English and those languages you don't know, but you can't tell them apart because you don't know enough about the language.
Can't tell what apart.
Let's say like Mandarin and Cantonese.
Can't tell that one, most likely not, but maybe with some training I could.
Yeah, with some training. And so if we wanted to train or if we wanted to get a machine to do this for us, we can think about, well, what would be some of its qualities and which languages are going to be more difficult than others. And by difficult, we have to be specific and say that we're talking about the type of machine it would take to recognize the language. So let's go back to sheep language. Basically, sheep language starts with a B, right? And then is followed by at least one A. Ba, ba.
Well, I don't really know. I think a sheep scientist would chime in, but you could just make up your simplified child's version, sure.
Well, in this regard, computer scientists do not speak to biologists. We just use this example like this because it worked quite well to describe regular languages.
Right, so in the made-up sheep language.
Yeah, starts with a B no matter what, has to be followed by at least one A, and one A is enough, but you can also have basically an infinite number of A's. So if I were handing you note cards with words written on them, how quickly could you tell if it was in the sheep language or not?
Very quickly.
How would you do it?
If it starts with a B and ends with an A, it's most likely a sheep language.
Yeah, well, what about all the stuff in between? What if it went
it could have
BZA?
You said infinite A's.
Yeah, but what if it was BZA?
Bazaar?
Yeah, I don't think sheep say bazaar.
Bazaar.
Mm-hmm.
Well, I think a sheep is capable of saying bazaar or making its utterance sound like that. So I would probably just deem it sheep-like.
Well, it's not about capability. I mean, I can say zigzag, but that doesn't make it an English word.
What is your question? Your question is, if you ask me to determine and guess, is it a sheep language or English? Then that's what I would say.
Not guess. We got to get this perfect. So essentially, you got to check, is there a B at the front, right? If not, you reject immediately. And if you do find a B at the beginning, you got to progressively check through all the letters. And as long as they're A's, you're good to go until it ends. But if you encounter anything else, you got to stop.
Well, you're assuming a sheep cannot mutate its ba, right?
Well,
It doesn't have room to change its language.
sort of. No, I'm not making that argument. I'm saying that the sheep language is an established language. And
That you made up, yes.
so in order to make a machine that can recognize the sheep language, it's actually quite simple. You only need something called a finite state automata, or a finite state machine. So it's kind of like a machine that can be in a certain state and then make a quick check, like what is the current input, and then transition to its next state. So the finite state machine for the sheep language, the first beginning, state, you just have to say, okay, I'm looking for a B. If you don't get it, you reject. If you get it, you go to another state that says, I want to make sure I see all A's until I get to the end of the word. And as long as you keep seeing A's, you stay in that state until it ends. Then you say, I accept this word. Otherwise, at any point, you reject the word. There's a lot of interesting properties about these finite state machines. You can make these very strong statements, for example, about the completeness of what the machine can do and will it stop on all inputs and things like that. It's a very simplified model of computation that basically has no memory.
It doesn't remember the future or the past?
Well, yeah, very few remember the future, but it also doesn't need to remember the past. That's the key observation here. For you to understand the sentence I'm currently saying, you have to wait until I'm done with it, and hopefully it'll make sense. I'm still getting there, but you have to kind of remember the earlier parts of the sentence, keep them in your memory. And you have to keep things you know about me in the memory. Whereas the sheep, all they have to do is be like, oh, am I listening to a new word or not? And then look for the B, and then just look for A's. They don't have to remember, oh, there's been 8 A's before this, or 9 A's, or something like that.
But they have to remember the B.
You've heard me talk about Brilliant.org before. It's the accessible learning platform where you can take courses like linear algebra, machine learning, and artificial neural networks. Have I mentioned that they have a great mobile app as well? Why not use it to turn your commute into a learning opportunity? Maybe commit to doing the problem of the week every Monday on your lunch break. Brilliant.org is extremely affordable compared to a lot of your other learning options, and there's an abundance of content and new things being added all the time. You can get the Brilliant app in the Apple App Store or on Google Play for Android users. It syncs perfectly well with your desktop, so if you want to just head there, that's fine too. Point your browser to brilliant.org/dataskeptic to get a glimpse of what they have to offer. Once again, that's brilliant.org/dataskeptic.
They don't have to remember, oh, there's been 8 A's before this, or 9 A's, or something like that.
But they have to remember the B.
No, once they've seen it, they just know, I'm not in that state anymore. I just know my current state.
I see.
It's sort of like a wonderful thing for a person who, is very boring and doesn't want to be challenged. They just have to know their current state and execute their action.
Well, if I was a sheep, I would take great offense to that, but that is okay.
Well, we'll see.
This is a made-up state.
Yeah, we'll see if the sheep lobby gets against
You're
this.
implying that sheep are boring, and we don't know that. They have facial expressions, so...
Yeah, maybe the sheep
That's a
people
different definition that we have not established.
Yeah, I don't know. Maybe the farmers of America are going to boycott the podcast.
Farmers don't raise sheep.
Ranchers?
I don't know.
Oh, I just insulted them again. I'm sorry, everybody.
I thought farmers grew things.
They can grow sheep.
Okay.
At least that's how it works in Minecraft.
Maybe, yeah.
But there are languages that you cannot describe by a finite state machine. Is that obvious or not to you?
A finite state machine. What is a finite state machine?
Oh, yeah. It's this machine that can recognize the sheep language. It has a fixed number of states and then rules for how you switch between states. And then, if you accept or reject the thing you're looking at.
So then go back to your statement. What is your statement?
Does it surprise you that I would say a finite state machine, this very simple model of computation, it cannot describe all the languages in the world?
Does it surprise me? No. If you said it's a simple state machine, it has no memory.
There is a proof called the pumping lemma, which I won't go deeply into here.
How do you spell that?
Pumping, like pumping a pump.
What's the second word?
Oh, lemma, Lemma.
Pumping lemma?
Yeah.
One word or two?
2 words. Don't worry about the detail. It's not necessarily actually, it's a fine name once you know the proof, but it doesn't necessarily explain itself. So allow me. It establishes that there are languages that are not regular, and a regular language is one that a finite state machine can recognize. The canonical textbook example is a little bit like the sheep example, but in this case you have to observe some number of B's, and then you have to observe the same number of A's. It's a harder language than the sheep language because you have to remember how many B's you've seen. And then as you get to the A's, you have to track that you get the same number.
The same number of A's and B's?
Yeah. Otherwise, it's not a valid word in this new hypothetical language.
So this is called a pumping lemma?
This is part of the proof of the pumping lemma, yeah. It just establishes that there are languages which are not regular.
What's regular mean?
Regular means it can be recognized by a finite state machine. It's the same thing as regular expressions, which a lot of people will be familiar with.
Okay.
It's generally used to kind of help parse stuff. So like if you had a bunch of phone numbers in a document, a phone number should be like in a certain format, the area code dash, the exchange dash, the last four, at least in the US, stuff like that.
So what if there weren't hyphens? You're saying this machine could not recognize the phone number?
Oh, well, so you could make a more complicated finite state machine that kind of recognized all the paths. So one path would be like, I look for parenthesis, 3 numbers, then parenthesis, and another person looks for just 3 numbers dash 3 dash 4. So those are all kind of valid paths, and a machine could learn to recognize all the fixed paths. And there, yes, it's counting how many digits. Like I said, 3, then 4 is an American number. However, that counting is like hard-coded in the machine. You're in the state of a count of 1, and then you transition to the state of count 2. It doesn't actually kind of store that number in memory or compare any of the numbers.
Does that mean it's regular or not regular?
Regular. Regular has to have this memoryless property. There's nothing auxiliary except your current state.
A memoryless property. Are you saying that if this machine identifies a number, then that number is regular or not regular? Or are you saying the machine is regular?
The language is what's regular, and the machine can recognize it.
So you're saying if this machine can recognize it, then it is a regular language?
That's right. Because of stuff like the pumping lemma, we know, there are more complicated languages. But even some of those are simple. There could be a language that contains all the words that have a certain number of B's, like I said, and then the exact same number of A's. So B, 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 A, A, A. That's in the language, right? But just rules clarification, what about B, A, B, A?
B, A, B, A. I don't know. We didn't talk about whether they have to be repeated after one another or not. So that leads me to believe it's allowed.
So I'm going to reject that. I'm saying the definition of this language we're making up has to have a certain number of B's followed by the same number of A's, and that's it. Nothing more, nothing less. So how about...
They can't alternate. They can't be in another pattern.
So in order to recognize words in this language, you have to kind of count the number of B's. I mean, the whole time you can stop anytime you get something weird. Like if a Z shows up, you just stop. But you count the number of B's, and then you have to kind of count down and make sure when you're done with the A's, you're at 0.
Well, you're saying you count up like 1, 2, 3, and then when you have the A's, you go 3, 2, 1.
Yep. And
that's one way to do it.
Yeah.
It doesn't mean all the ways.
You're right. I could stand on my head.
You could counting up. You could go 1, 2, 3, and then if A equals 1, 2, 3, then it matches.
Yeah, I could definitely do it in much more complicated ways, but the simplest way is what we tend to prefer, and I think that's the simplest way there is, to just count up, count down, because then I just need one number to keep track of. And also, for the more advanced listeners, we could say that this can be done in L space, I believe it is, because you really only need a logarithmic number of bits to store that number, because it's just a counter. But that's just an aside. So that language, you need a fancier thing than a finite state machine. You need something called a push-down autonoma. And it's basically a machine that has a memory where the memory is a stack. You can put things on top of the stack, and you can take the top thing off, but you can't look backwards in the stack too far.
Too far? Does that mean you can look backwards
No, at all. Sorry, thank you.
So you could look at the top one. What's an example?
It's a little bit like a card game, right? Where there's a discard deck or something. You can pick up the top card, but that's it. And then once the top card is picked up, there might be something underneath you can pick up then. But it has this kind of like top-only property because it's a stack.
Well, then order is very important.
Yeah, so you can imagine that this is helpful. Obviously, it can recognize more languages than the simple machine we started with because it has this little memory. Do you think the push-down automata could recognize English sentences?
Well, I don't know, but if you had a good set of rules and the right set of order, most likely yes.
So it is a very curious thing to think about. But there are proofs that no, actually, even with this type of machine, there are languages you can't recognize, even more difficult languages.
But you asked me English.
Yeah.
So you're saying I can't recognize English?
A push-down automata cannot, no.
Okay.
And the reason is because English has a lot more context and rules to it, and you would need more memory than just that stack.
Context, like grammar?
Yeah, grammar's part of it. Or I could just say chicken, gas, natural, oil, cooked. And those are English words, but it's not a real sentence.
But it doesn't matter. It's English.
No, it's not.
You didn't ask this algorithm, did it make sense? You asked, is it English?
Tell me, I don't see the difference.
Those words are English. You're using English words.
Oh, okay, so...
You didn't ask, did this sentence make sense? Did it actually fit all the rules of grammar? No. I mean, it could be like someone just knows a few words, like a baby. Baby understands English.
Okay, so...
But it doesn't know how to make a complete sentence. You can't rule out that the baby doesn't know English, though.
Interesting. You have a very sort of liberal arts point of view on this, I think.
And same with Yoshi. Yoshi knows certain words and what they mean. So does she know English? In a sense, limited, yes. Does she speak fluent English? No.
I think this might be one of those things that we're going to call an irreconcilable difference. Because let me tell you how I think about a language.
Well, this to me, this has been bothering me this whole show. It's
All right.
A lot of these things, like the term's regular, whatever, which means the other one is not regular.
Yeah.
I don't know what that means.
I grant you that one doesn't make sense.
It's insulting. And then the whole premise of your question, you said, is it English? And then your example actually had English words. So I just have to disagree with this Western train of thought. But anyways.
Well, hold on. You can't make it racist. It's not a Western train of thought.
It's not race, it's a train of thought, and I'm wondering if data science is created by the Western world without actually taking in diversity that exists in other areas of the world that could actually help solve problems in another way.
Well, all ideas are welcome, but the best ideas are mathematical, and mathematics are proofs, and proofs are independent of country and gender and race and everything.
You can say that, but I suspect the poorer countries that don't have math weren't able to contribute to these theories.
That may very well be,
chime in and try to pick them apart. So all I'm saying is that I would just put a footnote and say, well, until the rest of the world can chime in, and I assume that it's also driven by the U.S., which is an English-speaking country, it just seems like a very limited view.
So let me try and broaden the view then, because I don't see it the same way. Although perhaps the major discoveries were made by the subset of the population you're describing, that doesn't invalidate their proofs, nor in this situation does it mean that I think they're in any way being exclusive or xenophobic.
I didn't say they meant to be. Mm-hmm. By the history, it is limited view. It is a limited perspective.
Well, I'm going to disagree because here's the mathematical definition of a language. A language is a set of strings. And a string is any sequence made up by a given alphabet. So we have an alphabet that's agreed upon, and other languages have other alphabets. But nonetheless, you can put those alphabet characters into any order you want, jumble them up or put them in a special order, and you get a string, right? A string is just a sequence of characters. And the language is the set of those strings that are considered part of it. So when I say nonsense words, when I say a sequence of words that are in the dictionary but don't make sense together, we would say that string is not in the set of English utterances.
What do you mean? You could be making a list, a grocery store list. You're saying that's not allowed?
No, obviously you can do whatever you want. No one's prohibiting you from making your list, but you wouldn't say that the list is proper English, right? They're not sentences.
It's not sentence, but is it English? Yes.
Okay, in some definition.
Is it
sure.
Language? Yes. It could be communicating something. You don't know.
Right. So you're actually hitting on one interesting point here, though, that the boundary lines of language are very blurry as you get into the higher classes. So the sheep language, it's very obvious if it's in sheep language or not. English sentences, like what about the word ain't, right? It's debatable, is that proper English or not? And language evolves. What's the word you introduced me to? It was a good one. Some girl with her eyebrows or something.
Oh, fleek.
Yeah. What was the deal with the fleek?
Well, it's girl just made up this word and then everyone started using it.
Yeah, so clearly language is an evolving, fluid thing in actuality. Well, the formal mathematical theories don't necessarily account for that perfectly, but the basic idea when a computer scientist talks about languages, they mean the set of strings that are contained in the language. And there should be some formal definition of that set.
Contained in the language. That still matches a list, a laundry list of words. I just want to clear.
Right, but in useful orders, because some laundry lists of words are gibberish.
Laundry list may be in the prioritized order where the sheep is most important. You don't know.
All right.
But anyways, I think you should work on your definition if that is truly your definition.
This is not my definition. I'm following.
Well, then you're not defending it well to me.
All right, well...
I disagree with this, and I do not think that your explanation is sufficient.
Well, perhaps through our disagreement, we can still get to the main point here. And that's that even that push-down automata I described, which is a powerful machine, it has a memory, it's not capable of recognizing the highest class of languages. There are languages that can only be decided by a Turing machine.
What's the highest class of languages?
The hierarchy that I know is sort of like based on what machine it needs. Finite state machines are the simplest, then there's push-down automata, and then there's Turing machines. And I'm sure that linguists and people like that have like 1,000 other little ways they subdivide it. I don't really care about that stuff. So to me, it's like if the language needs a Turing machine to be recognized, that's sort of the highest class. Now, that's maybe a bit more general than if you went and looked at the literature, but that's what I can talk about today. In that regard, these theories are quite inclusive in that they don't say that any one language is better or more difficult than another. All human spoken and written languages seem to have this property of needing a Turing machine to recognize them. And in that way, none are better or worse than any other. They're all kind of computationally invariant.
Invariant.
Yeah.
What does invariant mean?
Invariant means equivalent or no different under small changes. You know, like I could program a computer one way and you could program it another and they could solve the same problem, but yours is faster in certain inputs and mine is faster in other certain inputs, but they're sort of invariant. Unless yours dominates mine all the time and then yours would be better, but invariant.
In theory, yes.
Yeah.
I like that thought.
Right. Well, then don't study Kolmogorov complexity because it's all about how translations and stuff make things invariant. But anyway, that's getting a bit theoretical for today. What I wanted to really get to is the fact that we can classify languages in this way, and perhaps you don't like the little hierarchy, but this is sort of the mathematical formal way it's done. And then as we have these classifications, what really drives them is the type of machine it would take to recognize them. And anything that's intuitively computable is computable on a Turing machine. So languages that require our most advanced computational device are quite interesting and also have a lot of incompleteness properties from time to time. We can't always make broad statements about them in the same way that you pointed out that language is kind of fuzzy and what is or is not English is sometimes a matter of debate, or at least in my mind, certainly an evolving idea.
And that is why we evolve. And that is why civilization is so interesting.
Yeah, maybe people will hear this in 1,000 years and we'll sound so old-fashioned. Maybe they won't even understand us the way I don't really understand Shakespeare.
I don't think they're going to hear this. There's so much data. We'll just get pushed down.
Yeah, I got to go do some keyword stuffing. So let me get to that. Thanks as always for joining me, Linda.
Thank you, Kyle.
Data Skeptic is a listener-supported program. To support the show, visit dataskeptic.com and click on the membership tab.